Now let us state and prove Lagrange's mean value theorem. So we make use of the Rolle's theorem to prove Lagrange's mean value theorem. So first let us state the mean value theorem. The statement: if f of x is a function such that it satisfies two conditions. First one is f of x is continuous in the closed interval a comma b, f of x is differentiable in the open interval a comma b, then there exists at least one point c belonging to the open interval a comma b such that f dash of c is equal to f of b minus f of a divided by b minus a. So thus the function f of x satisfies only two conditions here. If you take the Rolle's theorem, it satisfies another condition f of a equal to f of b. So now here you have only two conditions. Now let us prove this theorem. To prove this theorem, let us define a new function phi of x which is given by f of x minus k into x. Okay. Now we know that f of x is continuous in the closed interval a comma b and differentiable in the open interval a comma b. K into x, where k is a constant which is to be chosen later appropriately. So now k into x is an algebraic function which we know that it is continuous and differentiable in any interval. Hence k into x is continuous in the closed interval a comma b and differentiable in the open interval a comma b. Hence their difference, the difference of two continuous functions is another continuous function, and difference of two differentiable function is a differentiable function. Hence from these two we get phi of x is continuous in the closed interval a comma b and differentiable in the open interval a comma b. Now we have called this as a relation 1. From 1 we have phi of a is equal to f of a minus a into k, phi of b equal to f of b minus b into k. So now if phi of a equal to phi of b holds good only if f of a minus a k is equal to f of b minus b into k. So from this we get k is equal to f of b minus f of a divided by b minus a, which is called as equation 2. Now this relation holds only if k is chosen by as is taken as given by 2. So suppose if we choose k as given by 2, then the function phi of x satisfies all the three conditions of Rolle's theorem. That is, phi of x is continuous in the closed interval, differentiable in the open interval, and phi of a is equal to phi of b. So thus the three conditions of Rolle's theorem are satisfied. Hence according to Rolle's theorem, there must exist at least one point c belonging to the open interval a comma b such that phi dash of c is equal to 0. So differentiating, now how do you get phi dash of c? We need to differentiate relation 1 with respect to x. So we get phi dash of x is equal to f dash of x minus k. So that is what is written here. So now what is phi dash of c? Phi dash of c is equal to f dash of c minus k. So from this, and we know that phi dash of c is equal to 0. Hence we get f dash of c is equal to k. So what is k? From relation 2, k is f of b minus f of a divided by b minus a. Hence f dash of c is equal to f of b minus f of a divided by b minus a, and hence proved.